One of the great features of LINQ is that not only can you manipulate simple data like integers in an array, you can also manipulate objects. And to demonstrate that, we're going to work with an array of employee objects in this next example. And let's first take a look at the employee class that we'll be manipulating objects of here. So we have a class called employee, and an employee has three pieces of data: the instance variable monthly salary value, which we'll manipulate with the monthly salary property, which we'll define in a moment, and then also two auto-implemented properties, first name and last name. And as you recall, when you do an auto-implemented property, the compiler creates an instance variable for you for each of those properties. So first name, last name, and monthly salary value are pieces of data inside of an employee object. We provide a constructor for initializing all that data, and we also have a monthly salary property, which in the set accessor will perform a little bit of validation, simply ensuring that the monthly salary value is greater than or equal to 0, otherwise ignoring the value that's being assigned to the monthly salary. And finally, we have a toString method that just gives us a string representation of an employee consisting of the employee's first name, last name, and monthly salary, formatted with the first name left justified in a field of 10, the last name left justified in a field of 10, and the monthly salary value right justified in a field of 10 using currency format. So that's the employee class. And for the purpose of this example, we'll be using an array of employee objects. And you can see that for each of the elements of the array, we've created a new employee object that contains a first name, a last name, and a monthly salary value. And remember that the M, when appended to a numeric literal, indicates that the literal is of type decimal, as opposed to a whole number literal with nothing on it, which would be considered an int, or a floating point literal with nothing on it, which would be considered a double. So that's the array of employees that we'll be manipulating. And to show you the contents of the array before we do any additional LINQ, lines 21 through 23 display the contents of the original array. Now, when you take an employee object and output it using WriteLine, or any object for that matter, and output it using WriteLine, the WriteLine method calls the object's toString method to get the string representation of the object and then displays the string representation of the object. So when I run this program, we can take a look at the original array's values, and if you look here, we can compare the output to the set of values that were used to initialize the array of employees and see that indeed all the correct values were displayed. And again, notice the currency format. Because I happen to be running this in the United States locale on my computer, that's going to give me dollar and cents amounts. The format that you see here will depend on the locale of the computer on which you're running Visual Studio. Now, let's go ahead and take a look at our first LINQ example in this code. And for this query that we're about to look at, the purpose of the query is to find all of the employees that have monthly salary values greater than or equal to 4,000 and less than or equal to 6,000. So you'll notice a couple of things about this where clause. The first is that we're using properties of an object as part of the condition. And the second is that we're using a more complex condition as well by combining simple conditions with the logical AND operator. So if the employee that we happen to be looking at a given moment, if that employee's monthly salary is both greater than or equal to 4,000 and it's less than or equal to 6,000, then we're going to select that employee as part of the results. And again, lines 27 through 29 have not actually performed the query yet. This is just designating what we wish to get when we iterate through the query results. And that means that if we were to modify the contents of the employee array before iterating over the results, when we finally do the iteration over the results is when the query will be performed, and it will use whatever the current data is in the employee array at that moment in time. So lines 32 through 36 are going to display the specific employees that had dollar amounts in the range 4,000 to 6,000. And if we go back and look at the output window here, we can see that 3 of the employees had monthly salaries in that range, and you can confirm that the 3 correct ones were selected by looking at the original array up above. So the first item that was selected was Jason Red with a value of 5,000. That's the first item in the original array. And as we start looking down, the next item that's between 4,000 and 6,000 is James Indigo, which we see was the second object selected. And as we continue down, the next item in the range 4,000 to 6,000 was Wendy Brown, and that was the third item that we selected. So you can do much more complex where clauses by working with the properties within a given object that's being manipulated. Now the next part of our example demonstrates sorting by multiple fields. And in this part of the example, the way the code is originally written here, we don't actually show you the full set of sorted results. So I'm going to add some code in for a moment just to demonstrate that to you. But what we can see here is that the name sorted query is going to be selecting an employee from the employees array. And again, if I hover over that, I can see that employees is indeed an array, and I can see that E is being treated as one employee from that array. And the order by clause in this case uses a comma separated list of fields that we wish to sort the items by. So E.lastname is going to be the first field that we're sorting these objects by, and for anybody who has the same last name, we will also sort those by first name as well. And again, by default, these are being sorted in ascending order. So unless you explicitly use descending, always you're going to get ascending order on an order by result. And because we don't have a where clause here, all of the objects are going to be selected as part of the name sorted query. So because I don't actually iterate through the results in the subsequent code here, let me go ahead for a moment and add in some code that's going to display the results for us to show you the full sorted set of data. So I'm going to first skip a line, and then we can use a simple for each statement. So var e in name sorted. So we want to iterate through the name sorted collection, whatever that is, and we want to write out each of the items one at a time. So this little burst of code here will show me the completely sorted set of names, and if I rerun this program, we can go back up here, and we're looking at this chunk of the output right now, and you can see the names indeed are in increasing order, ascending order by last name, and for the 3 folks with the Indigo last name, we can see that their first names are also in sorted order. On the other hand, if I had not done comma e.first name in the order by clause, then what would happen is the Indigo employees would be listed in their original order from the original array. So let me go ahead and close that output window and remove the code that I just added. And now we get back to the original example and the other features that we're introducing. So in this little if-else statement here, we have 2 new features that we're introducing, the any method and the first method. The any method allows you to determine whether an IEnumerable object contains any elements at all, and the first method allows you to get the first item from that IEnumerable object. Now, based on what you know so far about object-oriented programming in C#, normally when you see an object name on the left side of a dot and a method name on the right side of the dot, you expect that method to be defined as part of the class of the object on the left side of the dot. And it turns out these are special types of methods in C# and .NET. They're called extension methods, and they're actually defined in a class, in this case called enumerable. I'm going to press F1 to bring up the online documentation here. The enumerable class contains many different so-called extension methods that you can apply to anything that is an IEnumerable object. In this case, the any method will tell me whether the argument IEnumerable object contains any items at all. And if I go back to the main listing of methods, we can actually see that there are many different methods that are available to us. So for example, if I wanted to have an array of 64-bit integers, and I wanted to determine the average of all of its elements, I could say array name dot average, and it will give me back the average of all the elements. And you'll notice that, going back to any here for a second here, you'll notice that the way it's being listed in the documentation is that it receives an IEnumerable as an argument, but the syntax for actually invoking it is to say .any with no arguments at all, and the compiler worries about actually taking what's on the left side of the dot and passing it into the any method for you. So these are interesting methods. The any method is going to return a Boolean value telling you whether there are any elements in this case, the name sorted query result. And the first method is going to give you back just the first of those objects. And one thing that's important to note about first is that it will throw an exception if there are no objects in the collection, in the result. So before you ever call first, it's important to know with 100% certainty whether there are any items in the collection. Now, if I go back over to the documentation here for a moment, you can see, again, there's lots of different possibilities for extension methods. We have an average capability. If I scroll down past that, some of the other things that you can do, a count capability, so you can count the number of items. There's a distinct method that allows you to get only the items that are unique within the object on which you call distinct, and many, many more methods. So what you're going to want to do is take a look at this enumerable class in the online documentation. The easiest way to get there is in this example to go back to my source code and just click in either any or first, and it will, and then press F1, and it will take you directly to the online documentation, or you can just search for class enumerable as well from the system.link namespace. Now, so if there are any objects in this example, we're going to display just the first one. So let me go back to my output window, and we can see that the first employee, after having sorted them by name, was Jason Blue. And of course, when I showed you the full list of sorted objects, you saw that as well. Now, another thing that's interesting about LINQ is that you don't have to select entire objects when you're manipulating objects in a collection. You can select portions of objects. So here we have a simple LINQ query that just says for each of the employees, select only their last names. And as a result, I would then be able to manipulate just the last names of all the employees. So the select clause can select individual properties of objects, and as we're going to see in a moment, you can actually create new data types on the fly using the select clause as well. Now, the last names query, we're going to iterate through down here in lines 59 through 61, but notice that we're not just iterating through all of the last names, we are invoking the distinct extension method, and if I hover over that, you can see that it's telling me that this is an extension method that returns distinct elements from a sequence by using the default equality comparer to compare values. So basically, it's going to compare all of the items in the last names collection, whatever that is, in this case, a list of names produced by a LINQ query, and it will give me back only the ones that are unique. Then I will iterate through the unique ones and display them. So if I go back up to the top of the code here and look at the original set of employees, we can see by looking at this that there were 7 different employees but only 5 unique last names. So when I go ahead and execute this for each statement at line 60 and 61, the resulting output shows me just the 5 unique last names. So you can select whatever portion of an object you want as part of a LINQ query, and the distinct extension method allows you to get just the unique values out of an object. Now remember, distinct is interesting because you can call it on anything that is IEnumerable. So for example, if I have an array of integers and I want to just get the unique integers in that array, I can say array name dot distinct, and it will give me back just the unique integers from that array. Or if I had an array of strings and I wanted to get just the unique strings, I could say that array name dot distinct, and it would give me back just the unique strings. The key is that the objects that are being manipulated have to be comparable with the to determine if in fact they are distinct or not. So basically a double equals style comparison in that case. Now let's go ahead and take a look at our last query in this example. And this query demonstrates how to create an entirely new data type on the fly as part of a LINQ query. So what we're going to do here is select from our employees array some new objects that will contain both the employee's first name and the employee's last name. And when you say select followed by the new keyword and a set of curly braces, what you're doing is telling the compiler to create what's known as a new anonymous type object. And it will basically create a class for you that consists of the fields that you list in the comma separated list here. In our case, it's going to be the employee's first name and the employee's last name, but for the employee's last name, we are renaming the property to be last. So the new anonymous type that we're creating is going to consist of objects that have a first name property and a last property. And to demonstrate what those objects contain, we will then iterate through the results and display them for you. Now it turns out that the anonymous class that's created also gets a free toString function, and if we take a look at the last part of our output here, you can see the format of that function, of that string rather, is to display the property name followed by an equal sign and the property value in a comma separated list that's surrounded by curly braces. So all of the formatting that you see here was generated for us by the compiler simply because we created a new anonymous type that contained just the first names and last names of each of the employees. And this is what's known as a projection of the data. So again, for those of you who are familiar with database manipulation and SQL, structured query language, it's very common to select subsets of the data within a given table, and that's called a projection, and you can do that in LINQ as well by selecting new anonymous objects that are created on the fly.